Remove nth node from end of list. So given the head of a linked list, we need to remove the nth node from the end of the list and return its head. Okay, so here in example 1, we're given that n is equal to 2. So we want to remove the second node from the end of the list, right? So the first node from the end is going to be 5. Second would be the 4 here. And if we remove that, then we'd have only the 1, 2, 3, and 5. That's how we get our output here, right? But if we only have like one node inside of our linked list, n would be 1, because like a constraint here is that n has to be between 1 and then SC, and SC is the number of nodes, so they can't give us some like crazy n. So yeah, if we have this and we have n is equal to 1, we'd pretty much return the first node from the end of the list. That would be, an empty list. So basically a good way we could do this is using a fast and slow node, or fast and slow pointer. Okay? So what that means is we can pretty much start two nodes off here at head. Okay? Or like, okay, so like an approach that someone might use at first is start two nodes off at head, and then push one of those pointers, or so I don't know what I said earlier, but yeah, start two pointers here at head. Push one of those pointers n iterations up. So if it's like 2 here, right? It would be 1, 2. So let's say our right pointer is here at 3 and left is at 1. And then we're going to iterate both right and left up 1 each time until right reaches the end. So when right reaches 5, left would be at 3, right? Because if left was here and right was here, they were 1, 2 apart, right? So then if right's here, then 1, 2, left would be here at 3. So 3 is, so we would then be at the pointer that we want to use to get rid of the 4, which would work. However, this does cause an issue when we only have a length of 1, or like when head's equal to 1, for example. Because if we start both the nodes at like 1 and then head, pretty much right pointer will reach the end instantly. Left can't use 1 to get rid of 1. Like it can't do that. So we're gonna have to use a different approach, right? So yeah, we'd have to use a different approach. Let's see. What we could do is we could have a dummy pointer, basically that comes before the 1, and have right and left both start at the dummy pointer, and have right once again iterate up n times, and then have left and right pushed over until right hits the end, and then left will be the same amount of iterations behind it. And we can get rid of the 4, but this also allows us to get rid of the 1 as well here in example 2. So that's how we do that. Okay. So what we can do is pretty much have dummy is equal to like list node none, dummy dot next is equal to like head. And for I in range n, we're gonna do, we'd have dummy and we'd also have So we'd have, so we could do left is equal dummy just to keep track of them easier, and right would be, right would also be equal to dummy. We'd be starting them at the same point, or yeah. I think that's right. Okay, well, let's test it. Why not? So if we have this here, just want to see. So if we have dummy, right? Left and right start here. So if I make right go up, say 2 times. So right will go up 1, 2, and then if we make them go all the way to the end, right would be there, left would be at 3 still. Okay, yeah. And we could still get rid of the 4. It would work. It would work out just fine. So what we can do is we can have right is equal to right dot next, while right and right dot next. We're pretty much now just going to iterate both them to the end. Right is equal to right dot next, left is equal to left dot next. Return. You can return dummy dot next. Because dummy is going to be pointing to the head. Or I guess we could just return head. Oh no, but I think head could get moved. Yeah. Return dummy dot next would work. Oh, I forgot to actually remove the node. Okay. So now we have left, we can do left dot next is equal to left dot next dot next. So that would point the, once we have the actual 3, we'd have to point 3 to 5. Alright, so the runtime complexity here, through both these iterations, right, we'll go through the entire linked list, so it's O(ven), and then the extra space is going to be O of 1, because we're not creating any new structures relative to the input.